Dear students, in this video lecture I will talk about chemical reactions, stoichiometry in chemical reactions and the limiting reagent. Before I start the discussion of stoichiometry and the limiting reagent, let me tell you about the chemical equation. Chemical equation is actually a representation of a chemical change, and this representation is done with the help of symbols and formulas. Different types of chemical changes you can see: addition reaction like H2 plus Cl2 giving HCl, decomposition, calcium carbonate when decomposes gives you calcium oxide and CO2 gas. Substitution, you can see H2 gas is liberated here when zinc is added to H2SO4. Rearrangement reactions, double decomposition. So these are the different chemical reactions. Now I will talk about the stoichiometry of the chemical reaction and the concept of limiting reagent. If I ask you that how many of you are aware of limiting reagent, then many of you will say, no, not aware. But actually, every person is aware of limiting reagent, although we don't know the name. First, let me tell you the definition, then I will discuss this in detail. The definition of limiting reagent is, it is that reactant which is consumed completely in a chemical reaction when reaction goes to completion. A reactant which is not consumed completely is referred as excess reagent. Now, to understand the concept of limiting reagent, I will ask you a question. If I mix 6 moles of NaOH, 6 moles of NaOH with 4 moles of H2SO4, then how many moles of Na2SO4 will form in the chemical reaction? Many of you will not be able to answer this. But if I ask the same question in another manner, like you all know that a motorcycle or formation or preparation of a motorcycle, we require 2 wheels. Let us say 2 wheels and one remaining part. So 2 wheels and one remaining part will give you one motorcycle. Now if I give you 6 wheels and 4 remaining parts, then how many motorcycle you can prepare? Now it's very simple. What will you do? You will take 2 wheels from here and one remaining part, and this way one motorcycle. Again you will take 2 wheels and from here one remaining part. You will get again one motorcycle. Again you will take 2 wheels and one remaining part. Again you'll get one motorcycle. But in the process you can see the wheels have finished. Now you do not have wheels, so you cannot get motorcycles more than 3. So at the end you will say 3 motorcycles we can get with the help of 6 wheels and 4 remaining parts. Now if you check, out of 4 remaining parts, 3 remaining parts have been used. So how many remaining parts left? 1. That is why this is our excess component, and wheels we can say as the limiting reagent. So that reactant, if I consider this as a chemical reaction, so that reactant which gets consumed first in a chemical process will be called as limiting reagent, and that component which is not consumed completely will be considered as the excess component. Now just compare this equation with NaOH and H2SO4. If I try to write the reaction, NaOH will react with H2SO4, and this way you get Na2SO4. At the same time, water will be formed. Now if you balance 2 NaOH, 2 H2O. Now easily you can see 2 NaOH when reacts with 1 H2SO4 gives you 1 Na2SO4 in the same manner as we did here. 2 wheels, 1 remaining part, 1 motorcycle. 2 NaOH, 1 H2SO4 giving you 1 Na2SO4. At the same time 2 water. So here 6 moles NaOH, here 6 fields. 4 moles of H2SO4, here 4 remaining part. So easily you can say if I take 2 of this, 1 of this, you'll get 1 Na2SO4. Again 2 of NaOH, 1 of H2SO4, you'll get 1 Na2SO4. Again you take 2 moles of NaOH and 1 mole of H2SO4, you'll get 1 mole of Na2SO4. This way at the end you get 3 moles of Na2SO4. And how many moles of NaOH will be left? 0. 0 moles will be left for NaOH and 1 mole of H2SO4 will be left. So H2SO4 is the excess component here, while NaOH is the limiting reagent. Here I told you the Gharelu method of finding the limiting reagent. Now I will tell you a scientific method. There is a standard procedure of finding limiting reagent scientifically. How to find limiting reagent? First point, write the balanced chemical reaction to know the stoichiometric coefficients of the reactants and products. For example, in the previous case, if I write, the equation will be what? Equation will be NaOH plus H2SO4 giving you Na2SO4 plus H2O. Now if I try to balance, it will be 2 and 2. So the coefficient of NaOH is 2, the coefficient of H2SO4 is 1, the coefficient of Na2SO4 is 1, and the coefficient of H2O is 2. So write the balanced equation to know the coefficients of the reactants and products. Now point number 2. This point says compare the coefficients of the reactants and then compare the given actual moles of the reactants. The reactant which is less in requirement is actually limiting reagent. I'll tell you. In the previous case, we have taken 6 moles of NaOH, 6 moles of NaOH and 4 moles of H2SO4. So 6 moles of NaOH and 4 moles of H2SO4. These are the actual given moles of the reactants, while 2 and 1 are the coefficients of the reactants. So guys, never change the coefficients. Never change the coefficients of the balanced equation. Whatever moles given, you write in this manner. You write initial moles, you write final moles. Initial moles before reaction, final moles means after reaction. So initial moles 6 NaOH given, so I'll write 6 here. H2SO4 given is 4 moles, I'll write here. Na2SO4 is not there initial, so 0. H2O is not there initial, so I'll write 0. Now final moles. As here you can see, compare the coefficients first. What will you say? 1 H2SO4 requires how many NaOH for the complete reaction? 2. So unitary method. 1 H2SO4 requires 2 NaOH. So if One H2SO4 requires 2 NaOH, then 4 will require 8 NaOH. 8 NaOH required if I consider 4 moles of H2SO4, but the given NaOH is only 6. 6 means less than the requirement. Less than the required means this will be the limiting reagent. My point is clear. You can also get your answer with the help of this. 2 NaOH requires 1 H2SO4. Since 2 requires 1, 6 will require 3. 6 will require 3 moles of H2SO4, but given H2SO4 is 4. That is why this is excess component. My point is clear. I repeat. Just compare the coefficients of the reactants first and then the actual moles. For example, in this case, the coefficient 1 H2SO4 requires 2 NaOH. So, given 4 will require 8 moles of NaOH, but the actual NaOH is given only 6, less than the required. That is why NaOH will be the limiting reagent here. The point is clear. This way we find the limiting reagent. And guys, please note the final moles of the limiting reagent will always be 0. Final amount of limiting reagent will always be 0. And the number of moles of all other components, the reactant or products, number of moles of all other components will be decided by the limiting reagent only. So this is point number 3. You can see here I have written, once limiting reagent is known, the amounts of all other components with the reactant or product will be decided by the limiting reagent. Final amount of limiting reagent is always 0. So I have written here 0. Now I have to find the number of moles of other components. Compare the coefficient of limiting with others. For example, if I compare NaOH with Na2SO4, you can say 2 moles of NaOH give you 1 mole of Na2SO4. 2 is giving 1. So 6 will give how many? 6 will give 3. 2 gives 1, so 6 will give 3. This way we get Na2SO4 number of moles as 3. Now 2 gives 2. Look at the H2O coefficient. 2 gives 2. So 2 gives 2 means 1 will give 1 means 6 will give 6. So how many moles of H2O will be formed? 6 moles of H2O. Now the remaining H2SO4 left because H2SO4 is in excess. So 2 consumes how many? 1. 2 consumes 1. 2 consumes 1. 6 will consume 3. 3 H2SO4 consumed. So left H2SO4 will be 4 minus 3 means 1. So at the end you can say NaOH left is 0. Number of moles of H2SO4 left is 1. Number of moles of Na2SO4 formed is 3 and number of moles of H2O formed is 6. This is the scientific way to find the limiting reagent and to find the amounts of all components after the reaction. Now to understand this, I will take another question here. Here the question says, find out the number of moles of all the components after reaction when 2 moles of N2 are reacted with 4 moles of H2 to produce NH3. So what will you do? First write the chemical reaction, balanced chemical reaction. Balanced chemical reaction N2 plus H2 giving NH3. You can see 2 nitrogens, so I'll multiply 2 here. Now 6 hydrogen, so 3. So this is the balanced equation where the coefficient of N2 is 1, coefficient of H2 is 3 and the coefficient of NH3 is 2. Now second step is find limiting reagent by writing the initial moles. Standard procedure. Initial moles of N2 is given as 2, H2 is given as 4, and S3 is given as 0. Now what will you do? Just compare the stoichiometric coefficient and then actual moles. What will you say? 1N2 reacts with how many moles of H2 to give 2NH3? 3. 1 consumes 3. If 1 consumes 3, then 2 moles will consume 6. But given is 4. 4 means less than the required amount. So, limiting reagent will be H2 in this case. Although, if you look at 2 and 4, you may think that 4 is greater than 2. But on that basis, we do not decide the limiting reagent. Limiting reagent is that which is less than the required amount. So required was 6, given is 4, that is why this is the limiting reagent. And what is the final amount of limiting reagent? 0. Who decides all the moles of all the components? Limiting reagent. So compare the stoichiometric coefficient of this limiting with others. Like here, 3 gives 2. If 3 gives 2, 4 will give. 3 gives 2, 1 will give 2 by 3, 4 will give 8 by 3. So you get 8 by 3, which you can write as 2.66 moles. Now for N2, you have to find remaining number of moles. 3 consumes 1. 3 consumes 1. So 1 will consume 1 by 3. 4 will consume 4 by 3. 4 will consume 4 by 3. So, remaining will be 2 minus 4 by 3, which comes as 2 by 3, and I can write this as 0.666 moles. So, the number of moles of N2 left 0.666, and number of moles of H2 left 0, number of moles of NH3 formed 2.66. Point is clear? Now, I'll take another question here. This question says, find out the amounts of all the components after reaction when 56 grams of N2 are reacted with 8 grams of H2 to produce NH3. The question is similar to the previous one. The difference is here the amounts are given in grams, mass is given, while in this case number of moles given. So if you want to use this mole concept, then convert mass into moles. So if I try to convert mass into moles, I will get N2 number of moles as 56. Mass upon molar mass of N2 is 14 into 2, that is 28. So this is 2. And H2 number of moles, if you try to find, the molar mass of H2 is 2. So number of moles of H2 will be how many? 4. Now, if you look at the number of moles of N2 and H2, the question is very similar to the previous one. Actually, it is the same question. So, in place of number of moles, if they give you mass, it is better you convert mass into moles and then use mole concept. Get the number of moles finally for different components. As you see, N2 left how many moles? 0.666 moles. So, if I want to find mass of this N2, I will multiply molar mass of N2, that is 28, with 0.666, and if you solve, the value comes as 18.6 gram. Similarly, NH3 formed. NH3 formed is actually 2.66 moles. Now 2.66 moles, if you want to convert moles into mass, just multiply the molar mass of NH3, which is 17, and if you solve, the value comes as 45.33 gram. So At the end of the reaction, the mass of N2 left will be 18.6 gram, mass of NH3 formed will be 45.33 gram, and mass of H2 left will be 0 because H2 is the limiting reagent. So this is the way we solve this question. But there is one more method, and that is the time saving method. There I will tell you mass concept. Here we have used mole concept. Again, you write the balanced equation first. N2 plus 3H2 giving 2NH3. Now we have to deal with mass concept. So I'll write initial mass and final mass. Final mass means after reaction. As we know, stoichiometric coefficients represent moles. So what we do here, do some groundwork, the coefficient into the molar mass, it is 28 gram. Here also 3 into 2 means 6 gram. Here 2 into 17 means 34 grams. So now instead of saying 1 mole requires 3 moles of H2, say 28 grams of N2 requires 6 grams of H2 to produce 34 grams of NH3. In the similar manner as we did earlier, initial mass we will write as 56 gram given in the question. Here H2 is given as 8 gram and NH3 is 0. What will you say? 28 gram N2 require 6 gram of H2. So 56 will require 12 gram. But given is 8 gram, obviously less than the required amount. That is why it will be limiting reagent. And what is the final amount of limiting reagent? 0. And which component decides the amounts of all other components? Limiting reagent. Now, you compare this mass with others. Like 6 gram H2 gives you how many grams of NH3? 34 gram NH3. So 8 gram will give you 34 upon 6 into 8. If you solve, the value comes as 45.33 gram. Now 6 consumes how many grams of N2? 28. 6 consumes 28. So 8 will consume how many grams? 28 upon 6 into 8, and this value comes as 37.33. So what will be the mass of N2 left after the reaction? 56 minus 37.33, and the value comes as 18.6 gram. So N2 left 18.66 gram, H2 left 0 gram, NH3 formed is 45.33 gram. So this is the mass concept where we have used the given masses directly. We have not converted masses into moles. While the same problem can be solved with the help of moles also. My point is clear? Now in the same manner, they may give you, instead of number of moles, they may give you volume at STP. For example, here the question says, find out the number of moles of all the components after reaction when 45.4 liters of N2 are reacted with 90.8 liters of H2 to produce NH3. Let me write the condition at STP. Now, here you can see volumes are given at STP. They have not given you number of moles. So what will you do? You convert volume into number of moles. How will you convert? Number of moles we know is volume at STP in liters upon 22.7. This way, the number of moles of N2 will come 45.4 upon 22.7 is 2, and number of moles of H2 will come 90.8 upon 22.7. The value will come as 4. Now you see, number of moles of N2 is given as 2, number of moles of H2 is given as 4. The question is similar to that question which we have already solved. So, in that way, if you solve, you can get the number of moles of NH3 produced. And in that question, we got the number of moles of NH3 produced as 2.66. So whether volume given at STP or mass given, you can get number of moles and you can use mole concept. My point is clear?